Now positive displacement pump. The pump, the pump. Pump is the device. It is a convert the mechanical energy to hydraulic energy. That's called your pump. Just we learn. Now displacement. What is the meaning of displacement? Suppose in a fixed section, okay, the point A, okay, to B. So the anything object will move from A to B. Again it comes back to B to A. Okay, B to A. It will move in A to B. Again it come back to A to B. So the distance or displacement. This is called displacement. This is moves in this A to B only. So that is called displacement. And positive. What is the meaning of positive means here? So this pump will provide a constant flow at fixed speed regardless of your change in pressure. If you are changing the pressure, if you are changing the speed, okay, but it doesn't matter. So any time the amount of water will flow from this pump is fixed, that is constant. So that's why it called a positive displacement pump. The pump makes the fluid moves by tapping a fixed amount, say fixed amount, okay, every rotation of the cycle, okay, forcing volume into the discharge pipe. So that is called your positive displacement pump. So all the positive displacement pumps are self-priming. Okay, what is the priming? We will discuss in the centrifugal pump or upcoming sessions. So these positive displacement pumps are three types. One is your reciprocating, rotary, and linear. So what is the reciprocating? Reciprocating means simple. If you see the picture here, okay, okay, and next one, the pump, we call the pump has a chamber or cavity or cylinder. This is called pump has this is called your cylinder, okay, or chamber, or you can call. So in this condition, the piston, this is the cylinder, in this piston will move, okay, front and back with action with help of your crankshaft. So this is the rotating in circular direction. It is moving in the linear motion, okay, up and forward and backward. This is called your reciprocating. This is called your reciprocating, and this is your circular motion, rotary motion. So this is the simple concept here. The pump has a chamber, cavity or cylinder between the plunger element. Okay, in this cavity, whatever the amount of water will store, in this cavity, okay, that is only for a shorter duration, temporary base. Okay, this is called your reciprocating pump. Okay, as I told you, this moved by using the reciprocating or rotary motion with the pipe and destination. So this means when your rotary motion is converting into the reciprocating motion of your piston, so that some valves open suction side and water will come into the cylinder or cavity. Again, due to compression of this piston in this cylinder, this exhaust valve, okay, or delivery valve open and water goes to your outlet. Okay, so these reciprocating pumps are again example or types are piston pump, plunger, and diaphragm. So piston pump, as I told you, this is example for the piston pump. Okay, here see the piston pump and plunger is there, long shaft is there. So this shaft will move up and down. This is called your plunger. And diaphragm. So diaphragm is, see, this is the diaphragm type pump. See, this is the diaphragm pump. Okay, in same, see, this is the section 1, water is coming and moving upward. So this is called diaphragm. Okay, we are not going to deeper. So this also be diaphragm type of pump. These both are diaphragm pump. Okay, this reciprocating pump are single acting and double acting. Single acting means water will come from only one side. See here, water is coming from only one side. But double acting means, see, the water will come, okay, from this way and this way, both side. Okay, this is called your double acting or multi acting reciprocating pump. Single acting means water will come from only one side, like this. Water is coming from only one side and goes from out is only one side. Okay, here the water inlet are two ways, okay, are going one way, or maybe another outlet also be there. That is called your double acting reciprocating pumps. So let us see. So single acting reciprocating pump. Single acting reciprocating means the forward or return stroke. During the forward stroke, so forward stroke means, so when the water will comes, this is the forward stroke, and return stroke means the vacuum will create. Okay, so the forward stroke or return stroke of the piston or plunger, in our every cycle the pump displays only one time of liquid which draws the water from only one side, as I told you. So how it comes the water in this cylinder is most important. When you are, so here see this picture, the water in your source, okay, that is at atmospheric pressure. This is exposed to the atmosphere. When the piston is moves backward, when the piston moves backward here, so due to this closed body, here the vacuum pressure is creates because the inlet valve closed and outlet valve closed. So here the vacuum is created. So this pressure in this cylinder is lesser than your atmospheric pressure. The vacuum pressure will always say that pressure in this cylinder is always lesser than your atmospheric pressure. So that due to this concept, okay, the water will move upward in this cylinder, moves upward in this cylinder. Okay, these valves, so this called suction side valve is, okay, one way valve. Due to vacuum, the valve is open and water will enter into this cylinder. Okay, during the forward stroke, again during the forward stroke like this, in this stroke, okay, and these valves are only one way valve, means one way valve. This inlet suction valve and delivery valves are one way valves. So that valve will open in only one way. So when the water will pushes from the bottom, then valve will open. But when the water pushes from the top, this valve will close. So that there is no chance to water comes down. So only other ways is that water will move upward. Okay, because the water density is constant, we can't compress. So that this piston will move, okay, compress the water in this stroke, in forward stroke, so the delivery valve will open and discharge will go through the your discharge pipe, or we call that is a delivery pipe. That is the delivery pipe. So the suction valve or suction pipe is there, so that the water at this suction side is lesser than the atmospheric pressure. So that in this region the water will come to your cylinder. Okay, and due to compression of the piston, okay, that will compress the fluid. Okay, the fluid will not, density is not constant, so that we can't compress the fluid. So due to that pressure, the liquid will pushes the outlet valve, so that outlet valve will open and water will discharge out. Okay, and here is the rotary motion. Rotary motion of your crankshaft will convert into the reciprocating. That's why it called your reciprocating motion. So based on this concept, the theoretical discharge of your single acting reciprocating pump is, so area, how much area of this cylinder, the area, okay, and how much cylinder this is, and total length L, this is the L, how much the piston is moving up and down, move, I mean front and backward, front and this way and this way. So this is called your stroke, this is called your stroke, that is called length. Okay, and total due to this cylinder area, total cylinder area, that is area into your stroke length. And this is crankshaft. Crankshaft is revolving, so that piston moves front and back, front and back. So that is called your delivery stroke, and one is your suction stroke. Okay, this stroke. So this RPM, speed of the crankshaft. Okay, this is called your rotary motion. This is called your reciprocating motion. So if you multiply all this thing, we will get area, length of the stroke, and rotation. RPM, minutes, RPM by 60, because we know the 1 minute is the 60 seconds. So this is the RPM. So this is the discharge of your single acting reciprocating pump. Please remember, this is most important. The question they will accept okay, in the examination. So one is your, the single acting reciprocating pump draws the water from only one side and discharge, theoretical discharge of this pump, this formula. Maybe you can please remember.